So coming on to the next type of compressor, in the previous class we have studied various types of compressors like vane bore compressors and screw compressors, lock compressors. Now in this class, coming on to the next compressor, we have the centrifugal compressor. The centrifugal compressor is basically the simplest form of compressor. It consists of an impeller or a rotor. You can see here this impeller on which the different at the same angles there are different kinds of vanes are being assembled on it. And as soon as the air is being sucked from the atmosphere through this impeller, the air is having some kinetic energy. And before starting the centrifugal compressor, we are supplying the mechanical power to the compressor. The mechanical power is being supplied only with the help of the electrical energy from the electrical source. As soon as electrical energy is supplied, this impeller starts rotating in the uh, clockwise or anti-clockwise direction. As soon as it starts rotating, it will generate the mechanical energy. As soon as the mechanical energy is generated, it will start sucking the air from the atmosphere. And whenever the air is being sucked into this impeller, or you can say the rotor of the compressor, there is generation of kinetic energy in between the air, and with the help of the generation of the centrifugal force, that kinetic energy is being converted into pressure energy before leaving the casing of the compressor. So again, that whenever you are supplying the electrical energy to the compressor, then that electrical energy is being used to rotate that uh, impeller or rotor of the compressor. As soon as it starts rotating, it will start sucking the air from the atmosphere, and the air is at the having only the pressure energy. But as soon as it is being sucked into the atmosphere, into the impeller or rotor, it will start rotating in the direction as similar to that of the rotor. And whenever it is rotating in the similar direction as that of the rotor, there is generation of kinetic energy in it because the air is in the motion now. But due to the centrifugal force and that kinetic energy is being converted into the pressure energy before it is being leaving to the another components of the pneumatic system. So the casing of the compressor is basically so designed that you can see these are the vanes of the impeller and these are the vanes of the these are basically the guide vanes which are guiding the air to the exit wall, or you can say the exit casing of the compressor. So as soon as the centrifugal force is being generated, it is converting the kinetic energy into the pressure energy. So that mechanical energy, initially we have electric energy which is being supplied from the source. As soon as we are supplying the electric energy from the source, that electric energy will be converted into the mechanical energy, and that mechanical energy is basically generating is rotating the impeller of the compressor. As soon as the rotor rotates, it sucks the air from the atmosphere and hence increasing the pressure of the atmospheric air due to the centrifugal force and the forces of the air to flow over the diffuser. So this is the diffuser which is having the guide vanes, and this is the impeller or the rotor which is having, or this is called the impeller also, and it is having some vanes. So the direction of vanes of diffuser as well as the impeller are in opposite direction, so as there is generation of more pressure energy within the air, and air uh, must be compressed to some extent so that its pressure must be increased. So here we are increasing the pressure of the air only with the help of the centrifugal force. As soon as the desired amount of pressure has been reached at the compressed air, then it is being supplied to the other components of the pneumatic systems. Next is the axial flow compressor. You can see from the figure that on the one side there is an inlet of the air from the atmosphere, and from the other side we have an outlet to the other components of the pneumatic system. So in the case of the axial flow compressor, you can see it consists of number of rotating blades and which are being fixed to a rotating drum. This central portion is a drum here, and you can see these are the fixed blades on the outer casing of the compressor, and on the drums we have some rotating blades. So on the drum, the blades which are being assembled on the drum can rotate, but the blades which are being assembled on outer casings are in the stationary positions. So as soon as the drum rotates inside an airtight casing to which are fixed at the stationary blades as shown in the figure, the blades are made up of some aerofoil section so as to reduce the loss which is being caused by the turbulence of the boundary separations. As soon as the drum starts rotating, it will start sucking air from the atmosphere, and that it is converting that mechanical energy. So that mechanical energy is being provided to the shaft through which the drum starts rotating. Initially, we are supplying the electrical energy to the drum, and that drum is receiving electrical energy, but it's converting the same as soon as it is rotating, the same is converted into the mechanical energy. So that mechanical energy is just being provided to the rotating shaft, or we can say it rotates the drum. As soon as the air enters from the left side of the compressor, on this side you see the cursor of the mouse. So this is the side from where the air is being entering into the compressor. As soon as drum starts rotating, the air is flowing alternatively in between the passage shown in the uh, passage which is being left over in between the fixed blades as well as in the rotating blades which are being assembled on the drum. So the air is being passing in between the passage of these or in between the sections in between the fixed blades and the rotating blades which are being fixed on the drum. So as soon as air is being flowing through the alternatively arranged uh, passage in between these blades, the air is flowing from these. It is being compressed as soon as it is flowing into the section of these blades. So this results in a successive compression of the air, and then and hence we have the at the last phase or at the exit of the compressor we have the pressure regulator from which we can see the value of the pressure, and as soon as the desired value of the pressure has been seen or achieved, you can open the exit valve and you can supply that compressor to the other components of the pneumatic system. So that is why you can see the air is being delivered at a high pressure at the exit point or the outlet point, because air is being compressed as soon as it is being uh, passing through the sections in between the fixed blades and the rotating blades. Is it okay? So next is they're having the capacity of the air tank. So this is very important factor in the section of the compressor. You can see the factor sometimes is really very difficult to determine, that is what is the capacity of an air tank. Obviously, the unit which is being selected should be very large enough to supply all the air devices which will be operating at any given time. So if all the air equations are being continuous, and you can say the capacity required is simply the sum of air consumption of each individual tool. That is, there are various kinds of components within the pneumatic system. You can see we have the air compressor, we have the air cylinder, we have the pressure regulating valves, we have the pressure safety valves, and other auxiliary appliances which are being uh, increasing the efficiency of the pneumatic system. So in most of the plants, you can see the air tools such as a chipping hammer, grinders, hoist are being operated intermittently. So achieving the 100% efficiency in the pneumatic system is not possible. So there may be some losses of the air, and there may be some drop of pressure within the pneumatic system. Is also, you can see the manufacturer of air compressor and air tools can often help in determining the capacity of the air that is being required to perform the any operation within the pneumatic systems. Next, we have the air cylinders. So what is the air cylinder? That is a cylinder which is being converting the pneumatic power, or you can say the power of the air or the fluid power to the linear straight line force at the motion. That is, it is being a prime mover which is converting that pneumatic power into the some kind of motion. That motion can be linear, rotary, or any reciprocating motion. So whenever you are receiving the power of the compressed air, or you can say the power of the compressed gas, that is pneumatic power, and you are converting that pneumatic power into the any kind of motion. That motion can be linear, rotary, or can be reciprocating also. This cylinder basically consists of a piston that is being located within the cylinder bore. That is, we have a cylinder arrangement in which the piston is being used to compress the air, and this compressed air is being uh, used to convert that pneumatic power into some linear or some other kind of motions. So these cylinders will be installed so that the cylinder is being anchored at a stationary structures, and you can classify these cylinders on the basis of their capacity. That is, these cylinders can be light duty, medium duty, or heavy duty with respect to the applications which are being used. So these cylinders may be single acting or double acting. That is, we have read in the previous class also. That is, if the cylinder is providing a delivery stroke with the single stroke of the piston, we are getting only the single delivery stroke, then it is called a single acting cylinder. But if you are getting the single double delivery stroke with only the single stroke of the piston, then it is called the double acting cylinder. So they may also be classified on the basis of their design. That is, if we are using the rod in between the cylinder, or you can say the two cylinders in the series or four cylinders in the series, they are called the duplex cylinders. But whenever we are using any diaphragm in the cylinder, that is called the diaphragm air cylinder. So they are being classified on the basis of their capacity. So first of its kind is light duty, medium duty, and heavy duty. Whereas on the basis of the operating principle, we have single acting and double acting cylinders. That is, if we are getting the single delivery stroke with a single stroke of piston, it's called a single acting cylinder. But if we are getting two delivery strokes with the help of the single piston stroke, that is called double acting cylinders. And we can also classify it on the basis of the construction and the design. So they are one piece welded cylinder. They are tandem cylinders. There are flash type air cylinders and tie rod cylinders. We do one by one all these kinds of cylinders. In single active cylinder, you can see we have only one inlet, and this is the outer casing. This is the you can firstly understand the construction of the air cylinder, selective air cylinder. This is the U cup seal. This is cylindrical body. This is the O-ring that is being, you can say the seals or the seals here. What is the necessity of the seal here? So that it can protect the leakage of any compressed air from the system. So and also protect the system from the impurities or the contaminants that may be added from the atmospheric air. So this is the end air and this is the piston rod which is being reciprocating in between the cylinder. So this is the outer spring which is being coiled, outer spring which is being coiled on the piston rod, and these are the bushes which are providing the cushioning to the piston rod, and with this cushioning we are reducing the frictional forces in between the piston rod and the end cover, and this is basically the piston height which is being reciprocating in between the piston cylinder. So this is the cylindrical body and piston spring, piston rod, and the bushes. So as soon as the electrical energy of the you can say the pneumatic power is being provided to this piston rod, it is being rotating, and with the single stroke of the piston, we are getting the single delivery stroke from this outer side. As soon as we are getting a delivery stroke, so that delivery stroke is being used to convert that pneumatic power into the linear motion, or we can say the any kind of motion which is required at the source end. In this end, you can see you can also employ this in the you can also take the example of the two-stroke engine, two-stroke petrol engine, in which we are converting that reciprocating movement of the piston into the reciprocating movement of the uh, connecting rod, and then we are converting that reciprocating movement of the connecting rod into the rotary motion of the crankshaft. That is why our vehicle is being rotating from one point of rotation to the another point of rotation. So for the constructions, we have well, this is the double acting cylinder. You can see the piston is being assembled in the middle portion. So we are having some O-ring, so double type O-ring is being installed here. Why we have installed a double type O-ring series here? Because the piston is moving in the either way, in the left hand side or in the right hand side, as per the delivery stroke, and it is providing a delivery stroke at the both ends. Whereas in the case of single acting air cylinder, we are getting the delivery stroke on the single side only. That is, we are getting the delivery stroke once with the single motion of the piston. But here, with the single motion of the piston from to and from one end to the other end, we are getting the two delivery strokes at, on the left hand side as well as on the left hand side, on the right hand side. So this is basically possible because we are having the two types of suction strokes and two delivery strokes in the with the which are being operated with a single kind of distance. So the forces being exerted by the compressor moves the piston in two directions in the case of the double acting cylinders. So these are particularly when the piston is being required to perform work not only on the advance movement but also on the return movement. That is, we are not only getting the delivery stroke in the forward directions of the pistons, but as well as we are getting the delivery stroke in the backward motion of the piston also. So you can see the stroke length is being unlimited in this case. Also the buckling and bending is before this setting, particular kind of pistons, because if the buckling or bending may occur in between the pistons, so it cannot provide the actual kind of delivery stroke while in the forward direction or in the backward direction. Next is the piston type S cylinder. You can see on the right hand side, this is the figure in which we are using the piston type S cylinder. So in this cylinder, in which the cross section area of the piston is basically less than, you can say, one half the cross section area of the element. So this is the piston which is having some clearance in between the inner diameter of the cylinder and outer diameter of the piston. So this type of cylinder is mostly commonly used in which we are the piston is being rotating in between cylinder. So this is also the example of the single acting piston cylinder or in the double acting piston cylinder. So in the double acting piston cylinder, we are also using the piston here, but in the double acting, we are getting the two strokes with a single stroke of piston, whereas in the single acting cylinder, we are getting single delivery stroke with the single stroke of the piston. Next is the diaphragm type. So diaphragm type it is in this cylinder there is a built-in diaphragm which is being made up of that may be made up of rubber, plastic, or even metal that replaces the piston here. So that piston rod is being attached to the center of the diaphragm. So there is no sliding seal because the diaphragm is actually acting the tracking or seal which is preventing the atmospheric air to enter from the atmosphere and also preventing the leakage of the compressed air from the system. So there are no chances of leakage of compressed air from the system because the diaphragm is automatically acting as a it's itself acting as a seals and tracking and also prevent the compressed air to leak from the system. So there is no sliding seal. So only the friction due to the stretching of the middle actor. So these frictions can be prevented by assembling the some bushes or you can say the clamping in between the surfaces where the diaphragm and the cylinders are meeting. So they are also applied in the manufacture of tools and fixtures, also in the rig. So you can see this is an example of the rolling type. This figure is showing the rolling type diaphragm cylinder in which you can say this diaphragm has been rolling and compressing the air from and sucking air from the atmosphere. And this is the inlet port, this is outlet. And as soon as the diaphragm is increasing the pressure with the considerably in the large stroke of the air and compressing the air to some extent. And as soon as the desired value of the pressure is being achieved, it is being supplied to the outlet port. Next is the tandem cylinder. So this is very important from exam point of view. This is tandem cylinder. So you can see here there are three or four kind of cylinder which are being connected in a series. So what is the use of the tandem cylinder? We have only single piston. We have a single rod which is operating all the four cylinders here. In the previous cases or in the previous type of test, we have read that only a single piston was there for and a single cylinder was there. But we are getting the two delivery strokes in double acting cylinder, but and getting the single delivery stroke in the single acting cylinder. But in the case of the tandem cylinders, you can get as many as that of the delivery strokes as that of the number of cylinders which are being assembled in the series. You can see there are four cylinders here, A, B, C, and D, which are assembled in the series, and only a single piston rod, which is being, or you can say, a sliding spool is there, which is operating all the pistons here. You can operate different kinds of systems. So you can operate, let us say, one cylinder is being required for a operating single pneumatic system. So that if you are tending this four cylinders and operating this four cylinders and compressing the air and converting the pneumatic power into the converting the pneumatic power into some kinds of forces into the another form and supplying that pneumatic power to different kinds of pneumatic systems. So that is this tandem cylinder you can operate four kinds of or three kind of different pneumatic systems with a single tandem cylinder. So in the tandem cylinder we have three or four cylinders here and in a so we are having four kind of delivery strokes here A, B, C, and D. And all these four kinds of delivery strokes are being operated by single-handedly by the sliding spool. So this sliding spool is handling all the cylinders. And what is the advantage of this tandem cylinder? You can operate as many as pneumatic system as the cylinders in the tandem cylinder. So if you are having three cylinders in this tandem cylinder, you can operate three pneumatic systems. That is, you can provide that same pneumatic power to three different systems. Like in the case of the laptop, you can uh, say that you can provide or you can send the data in three number of pen drives from a single laptop. So similarly, in this kind of tandem cylinder, you are providing the pneumatic power to three different ports. So you can operate three different pneumatic system with the same kind of a tandem cylinder. So you can see here in some applications we are also having some control valves and actuating cylinders. So all these cylinders are having their separate control valves, their separate pressure regulators, and but they are only having the single sliding spool which is rotating the pneumatic power and converting that pneumatic power into the different kind of motion. Let us say you are getting the linear power at A point, you are getting the rotary motion in B point. At C point, you are getting the reciprocating motion, or you can say the oscillating motion in the last one. So you can convert the single form of pneumatic power into the different kinds of motions at different points of the same convention. That is, at first point we are converting that pneumatic power to linear motion. At second point we are converting that uh, pneumatic power into the rotary motion. In the third point we are converting that into the power into the reciprocating motion. And the last we are converting that pneumatic power into the oscillating motion. So you can convert the same kind of power into the different kinds of motions. So next is the air cylinder. We have read in the hydraulic system also what is the function of the filter. So filter is basically providing the preventing the entrance of the impurities from the atmosphere, and it is also condensing. In the case of the pneumatic system, you must note down that there should not be any water vapors from the atmosphere that should enter into the pneumatic system. That is, if there is any water vapors may be present in the pneumatic system that may choke the system. So there should not be any water vapors. So the air filters are also condensing and removing the water vapors that may be present in the pneumatic systems in the case of the air filters. And they're also arresting any uh, unwanted particles, or you can say the contaminants that may pose a problem in the system components. You can see here, so this is the water drain wall. As soon as the water is being condensed, it is being settled down in the lower portion of the distance, and as soon as there is a collection of the water vapors, so you can remove uh, these water vapors from the water drain wall. This is the plastic bowl outer casing of the filter. This is the baffle, this is the filter strainer, and this is the deflector. This is the function of the deflector. It is as soon as the air is being entering into the air filter, it is forcing the air to be passed through this filter. So this is the function of the deflector, that as soon as the air is entering into the filter, it is being forcing the air to passing through that air filter. And as soon as it is being passed through the air filter, the water vapors are being condensed and they settle down in the lower portion of the filter, and the filtered air is being passing through the outer wall, or you can see the exhaust wall of the filter. Next is the pressure regulator. So what is the function of the pressure regulator? So the main function of pressure regulator in the pneumatic system is to basically regulating the incoming pressure of the system so that the desired air pressure is being capable of flowing at the steady conditions. So whenever the air is being supplied to the pneumatic systems, that pressure regulator is maintaining the uh, amount of pressure, or maintaining the pressure of the compressed air within the systems. That is, if there is any drop down in the pressure within the pneumatic system to provide a signal to the user, that is, the pressure is being dropping, so that uh, there is a need of suction of more air, or you can see there is a need of supply of more compressed air from that compressor, and thus maintaining the desired amount of air pressure within the pneumatic system. So this pressure regulator is basically having a metallic body with two openings. You can see this first opening is called the primary opening, and second is called the secondary opening. As soon as the pressure regulation is achieved by opening this poppet valve, this is called the poppet valve, and to a made amount of compressor, the desired pressure level will be achieved. So this is being done by the adjustable screw, which is being there. You are adjusting the screw. So as soon as you are adjusting the screw, you can see it is having a retracting spring. So as soon as you are adjusting this screw, this retracting spring will compress and it will increase the pressure of the air. So as soon as the pressure may drop down, as soon as it is being entered the pneumatic system, you can increase the pressure of compressed air by just adjusting this screw, and hence compressing the spring, it will increase the pressure of the air within the system. Next is the lubricator. So what is the use of the lubricator? You can see the figure here. Is uh, the principle of the lubricator is similar as that of the venturi meter. In the venturi meter, we have read in the fourth chapter that the principle of the venturi meter is basically based on uh, the knowledge. So you can see first portion is the converging portion. This is called the throat. That is in which the diameter is constant. This is the last portion of the venturi meter. This is called a diverging portion, in which the diameter is increasing from entry to exit, whereas in the compressor, converging portion, the diameter is decreasing from entry to exit, and the diameter remains constant in the throat, or you can say the throat body. As soon as this compressed air is being entered from this converging portion, you can see we have installed a converging nozzle here, or you can see the converging portion. So as soon as the diameter is decreasing, there is a decrease in the velocity of the air. So as soon as the velocity of the air is increased, the pressure will drop down, and there are some oil droplets is being dispensed in this portion. So air droplets are being entering into this because the pressure is increasing and will suck the oil droplets from this portion. And as soon as air is being passing through this diverging portion, there is again decrease in the velocity of the air, and hence there is increase in the pressure of the air. So as soon as there is increase in the pressure of the air, this oil which is being heavy as compared to that air droplets, this oil droplets will settle down in the oil reservoir, and hence removing the all kind of mist, or we can say the lubricants or the oil that may present into the atmospheric air. So this is basically the principle of the basic principle of the lubricator is to separate all the oil droplets or any mist present in the compressed air, so that these mist or the oil droplets should not enter into the pneumatic systems. We have to keep a check on that. That is, only compressed air must enter into the pneumatic system rather than any, and we have to prevent entrance of any oil droplets within the pneumatic system. So this is the lubricator is basically separating the oil droplets from the compressed air. So due to this, the oil is being pushed to the pipe and the air is being fed to the oil reservoir. To the you see here, the oil is being picked here from the oil reservoir, and air is being here. This is a simple air, that is the normal air, atmospheric air, which is being entering from the atmosphere, and it is being compressed. Air is being supplied. As soon as the compressed air is being supplied, its pressure is initially will drop down as there is an increase in the velocity. And as soon as this passing through total wall, it is separating the oil droplets from the compressor air with the principle of ventimeter. And as soon as it is reaches to the diverging portion of the lubricant, and there is again decrease in the velocity, and vice versa, there is increase in the pressure of the compressor. That is, we are not decreasing or increasing the pressure of the air from the final inlet to the final outlet of the lubricant, but we are only separating the oil droplets from the compressed air through this mechanism. So this is last is the installation and maintenance of the air cylinder. That how you can install and maintain your air cylinders. You can read, these are the applications of the air cylinder. So anybody having any doubt, you can ask me.